Hi kids, now we'll be going with this paper discussion. You can look into the first question. The first question says, a student measures time period of 20 oscillations of simple pendulum 5 times. The data set is 53 seconds, 52 seconds, 55, 54, 51. So if the minimum deviation in the measuring clock is 1 second, so that is like the error here is 1 second. Then how we should report the time? So first of all, we have taken 5 readings. So we'll be taking the average. Then we'll be getting 53. So what is the error for the first one? 0. Error for the second one, 1. Third one, 2. Fourth one, 1. Fifth one, 2. Right? 53 minus 51. So average of the errors will turn out to be 1.2, but error can't be so accurate, so we need to round it off to 1 second. 1.2 second is like so accurate thing, right? How can the error be so accurate? So what is the average value? 53. What is the average error? 1. So 53 plus or minus 1. That's how we need to denote it. The next question is, sphere of mass m and radius r rolls on a horizontal plane without slipping with speed u. Now if it rolls up vertically, then the maximum height attained would be. So what will happen? There somewhere it is pure rolling. The meaning is it is having translational kinetic energy and rotational kinetic energy. When it is going up, translational kinetic energy will start reducing. When the translational kinetic energy start reducing, rotational kinetic energy also will be reducing, because they said it is pure rolling. Pure rolling in the sense, in this particular question, V equals to R omega. So translational kinetic energy plus rotational kinetic energy. Moment of inertia about axis passing through center of mass, I am taking it as beta mr square. In this question it is 2/5. So R omega is V. So I can write the kinetic energy as this one. Where is this total kinetic energy going? This is translational kinetic energy plus rotational kinetic energy. Where is this total kinetic energy going? It is going as potential energy. From there you will be getting what is the maximum height travelled. In the following common emitter circuit, beta value VCE, VB are given. You need to find IB. So this is the given circuit. So in this they have given VCE 7. So the meaning is, if this is 0, this is 7. And VBE is negligible. So if this is 0, this is almost 0. So if this is 0, this is almost 0, so this is 0. If this is so this is 0, this is 0, so this will be 15, 15, 15. Yes, so and this resistance is 2 kilo given. And they said beta value is 100. So the meaning is current in this one by current in this one is 100. Or 100 times of this current is this current. Now 100 times of this current. 100 times of this current. What is this current? 15 minus 0 by RB. 100 times of this current equals to current in this. 15 minus 7 by 2 kilo. But they didn't ask RB value, they just asked what is the current in this. So I need to find what is this value. This value is how much? This by 100. From there you will be getting the required answer. Now the next question is asking like which is AC, which is alternating. Now all are alternating, like for some time the EMF is trying to drive the current in one direction, for the other time it is trying to drive the current in the opposite direction. Or I can show you, like later on you will learn in future, like sinusoidal is the basic variation. So any graph can be built as summation of different sinusoidal curves. So this graph can be built as different sinusoidal curves. This graph can be built as different sinusoidal curves. This graph also can be built as different sinusoidal curves. So all are AC only. A small solid ball dropped from height h above the free surface of a liquid. It strikes the surface at t equals to 0. The density of the material is given and that of liquid is given. The ball momentarily comes to rest 2 seconds at t equals to 2 seconds. Then the initial height of the ball from the surface of the liquid. So the question goes like this. A ball is dropped from here. So while it reaches here, it will have some speed. Now after that, after entering, its speed is reducing and it is becoming 0. The time taken from here to here is 2 seconds. 2 seconds. Now why it is reducing? Because there will be deceleration here. We will see why the deceleration is. Buoyancy will be density of the liquid into volume submerged into G. Weight of the liquid is density of the weight of the body is density of the body into volume into G. Now which is more? Buoyancy is more. So the meaning is once it enters the liquid, more force will be in the upward direction. So what is the acceleration in the upward direction? Net force in the upward direction is buoyancy minus weight. That equals to mass times of acceleration. From there you will be getting acceleration is magnitude by G in the upward direction. So velocity is U, acceleration is G. Now after 2 seconds it is coming to rest. So we can calculate what is the initial velocity. V equals to U plus AT. Final velocity is 0. Initial velocity is U. Acceleration is G in the upward direction. So minus G into time is 2. So U is 20. So the meaning is it will be entering with speed 20. If it is entering with speed 20, from what height I should have dropped, I can do energy conservation from here to here, or V square minus U square equal to 2AS I can do. 20 square minus 0 square equals to 2G h. From there I will be getting from what height we will be dropping. So when we drop from a height 20, it will reach here with a speed 20, and after 2 seconds it will be coming to rest. The relation between horizontal magnetic field, earth magnetic field and vertical component. So that's a very basic. So actual earth magnetic field will be somewhere in this direction. So when you resolve it, you will be getting horizontal component and vertical component. The angle between actual magnetic field and horizontal component is called as that dip angle. So the angle between actual magnetic field and horizontal magnetic field, that is called as dip angle. Horizontal and actual magnetic field, this is dip angle. So actual magnetic field cos delta is horizontal, sin delta is vertical. Cos delta is horizontal, sin delta is vertical. Fine. A hollow metal sphere of radius r is uniformly charged. The electric field due to this sphere at a distance r. Now for a hollow sphere, field inside will be 0. Field inside will be 0. But on the surface it will be kq by capital R square. Thereafter it will reduce inversely. For outside people you will be feeling like it is like a point charge. So kq by R square, inversely proportional to. Anyway, so what they are asking. So when you are increasing distance, but when it lies inside it is 0, but outside it is going to reduce, inversely proportional to R square. So option 2 will be correct. 0 as R increases from here to the surface, and decreases as R increases from surface to infinity. The value of numerical aperture of objective lens of microscope is 1.25. If the light of wavelength, then minimum separation between 2 points to be seen as distinct is. So that's the minimum distance between 2 points which you can see. So that's the thing. And this is numerical aperture. This is n sin beta is numerical aperture. Okay, fine. So you can take it like this is 0.61 lambda by numerical aperture. 0.61 lambda by numerical aperture. These two values are given in the question. Just substitute it and get the answer. A uniform circular ring is rotated. So you need to find what is the increase in the radius of the ring. So first of all, we need to think in terms like why the radius is increasing. So when you try to rotate, so there will be tension. Why there will be tension? Because of the expansion. Young's modulus is force by area, stress by strain. So why is force coming into picture? Because there is change in length. Actual length is 2 pi r. So change in length will be 2 pi delta r. 2 pi delta r. So there is change in length. So force is coming into picture. So basically, if we can find the tension, then we can find everything. So how to find the tension? I will be drawing the free body diagram of half part. So then there will be force tension from this side and tension from this. I mean, this is one half of the ring, this is the other half. So this other half will try to pull it with tension and tension. So these are the only two external forces. Net force in this direction equals to m into total mass into acceleration of center of mass. What is the total mass? M by 2 into center of mass is performing circular motion. So center of mass will have acceleration omega square r. Omega square, radius is 2r by pi. So net force towards the center equals to m omega square into center of mass position, center of mass radius. Right. So from there you will be getting tension, but tension you can just substitute this, then you will be getting the required answer. Right. So the only important thing is drawing the figure and writing this equation. If you take half ring, you don't have to do integration, but if you take any small element, you have to do, you don't have to resolve also vectors. But if you take any small element, you may have to resolve vectors. A uniform chain of mass m and length L hangs on a thread and touches the surface of the table by its lower end. Find the force exerted by the table on the chain when the half of its length has fallen on the table. The fallen part doesn't form heap and doesn't bounce. See, now let us go with generalized case. Let me say this x length has fallen here. So what is the weight here? Lambda into x into g. So that is the weight. Not only that, now once x has fallen, what will happen? The remaining part will be having some speed. Once x length has fallen, then the remaining part will be having a speed root of 2gx. Anyway, let me say this part has fallen here, and this point, this is coming here with a velocity v. Now what will happen immediately after hitting? Its velocity will become 0. So the meaning is, it is carrying momentum, this part is carrying momentum, but it is hitting and it is stopping. So how much force the chain is exerting on the ground? It is exerting weight plus it is going and hitting and changing the momentum. So there are two components. One component is weight, the other one is momentum thing, change in momentum. Now if small length dx is coming, with what momentum it will be coming? Lambda into dx is the mass into v. Lambda into dx into v, that is the momentum. So rate of change of momentum is by dt. Now what is dx by dt? Dx by dt is nothing but v. So this is lambda v square, v is root of 2gx. So what you can see weight plus weight of the fallen part plus twice the weight of the fallen part. Twice the weight of the fallen part is because of hitting, small element hitting, right? So what is the total? Total is 3 times of weight fallen, 3 times of weight fallen. So in this particular question, how much is the weight already fallen? Mg by 2. So 3 times of mg by 2 will be the answer. A body is projected away from the Earth's surface with 3 times of escape velocity. The speed at infinity will be. See, what does it mean by escape velocity? There will be some potential energy. When you give kinetic energy, it has to reach to infinity, right? Or if the total energy is 0, we call it as escape velocity. But in the next case, what you are doing? You are giving 3 times of escape velocity. Now I can write the same thing as half mv square plus 8 times of half mv square. But what we know about this one, this is going to be 0. So the meaning is this energy is sufficient for us to take it to infinity. So at infinity, what energy is left over? This energy will be left over. I can write the same energy as this way to see what is the velocity at the infinity. What is the velocity at the infinity? 2 root 2 times escape velocity. In a cyclic process, okay, so AB, BC, this is CD and DA, the efficiency of the process. AB, BC, CD, DA. So you know energy conservation delta Q equals to delta U plus W. Now for a cyclic process, delta U is 0. Now in this particular question, 800 minus 300, this is 500. So if this is 500, this is going to be 500, right? So efficiency is work done by heat taken. Work done is how much? 500. Heat taken is only the positive quantity is 800. That will give us the efficiency, right? Potential energy function is given. You need to find the equilibrium position. So equilibrium in the sense net force must be 0. So potential energy is this one. If you want to find the force, minus du by dx, when you differentiate it, you will be getting the force. When it will become 0, when x equals to 3 by 2. Which of the following devices eddy current effect is not used? Okay, in electric heater, eddy current effects won't be used because like you can directly connect any coil to circuit and still it will behave like a heater, right? Anyway, if you want to see like eddy currents are used for what all purposes majorly, this is from NCERT. 2 identical photons of energy E falls on 2 different metals whose work functions are in the ratio 1:2. The ratio of kinetic energies of most energetic electrons coming out from the metal are 2:1 ratio. So work function of one metal is 4 electron volt. What is the energy of the photon? So there are 2 situations. We need to write 2 equations. So first metal, photon energy minus work function equals to maximum kinetic energy. They said, okay, in the second one, this ratio is 1:2, they said, so I have taken this as phi, this as 2 phi. And they said kinetic energy ratio is 1:2, so I have taken this as k and I have taken this as 2k. Now that's all. Now, but they didn't say like whether phi is 4 electron volt or 2 phi is 4 electron volt. They said one of the work function is 4 electron volt. So what I am doing, I am taking what happens if phi is 4 electron volts. If phi is 4 electron volts, this one will turn out to be this equation, this one will turn out to be this equation. Then I can take the, okay, so I can substitute this k, hf minus 8, and I can solve for it, but none of the option is matching. Now what happens if I take 2 phi is 4, then the first equation will turn out to be this one, second equation will turn out to be this one. Again, instead of k I will be writing hf minus 4. When I solve it, I will be getting hf as 6, which will give us option 1. A solid conducting cuboid of dimensions, mass, resistivity, density are given. Battery is connected across different phases. Maybe first time like this phase and the opposite phases. Yeah. So there are 3 possibilities. One is this one, this one, this one, this one, up and down. Okay. Powers are P1, P2, P3. So given that P1 is to P2 is to P3, A is greater than, B is greater than, C they have given. So now voltage is constant, so I can write power as V square by R. But what is resistance? Resistance is rho L by A. Now if I connect it between these two sides, length is going to become A and area is going to become B into C. So what I want to do, I am trying to make like it into single variable so that I am multiplying and dividing with L. So if I multiply and divide with A, in this particular case, if I multiply and divide with A, what I will be getting rho A square by volume, So resistance is proportional to length square. So what I can write this one as 1 by L1 square, 1 by L2 square, 1 by L3 square. And they gave this ratio as 1:2:8. Now, so this has to be like 1 by A square, 1 by B square, 1 by C square, or 1 by C square, 1 by B square, 1 by A square. But given information is A is greater than, B is greater than C. A is greater than, B is greater than C. So this is going to become 1 by A square, 1 by B square, 1 by C square. C is less. So 1 by C square will be more. Okay, c is less, so 1 by c will be more, 1 by c will be more, 1 by c square must be more. So this is 1 by c square, this is 1 by b square, this is 1 by a square. So 1 by c square is 8, so c will be 1 by 2 root 2. Okay, I'm 1 by 2 root in the sense there will be some constant thing. So what I can say c is nothing but, or okay, they have asked to find c. In the options are c. So we will try to write everything in terms of c. So what is a? A is 2 root 2 c is nothing but a. 2 root 2 c is nothing but a. Okay, a is 2 root 2 c. Now similarly I can multiply and divide. So b by 2 is nothing but c. So b equals to 2c. So mass is density into volume. Density into volume is a into b into c. A into b into c. So from here we will be getting a is 2 root 2 c, b is 2c, and c is c only. So from there we will be getting the value of c. Right. An organ pipe of length is open at one end and closed at other end. The air column is vibrating in second overtone. The minimum distance from open end where the pressure amplitude is half of the maximum value. So this is how the second overtone used to look like. Pressure here will be minimum, pressure here will be maximum. So 1, 2, 3, 4, 5, 5 lambda by 4. 5 lambda by 4 equals to L, lambda equals to 4L by 5. Now we need to find, now this is like a sine curve, right? It is starting at 0, maximum, 0, I mean maximum magnitude wise, 0, maximum. So when it will become half of maximum, when it will become a by 2, 1 by 2, when will sin theta become 1 by 2? When the angle is 30 degrees, 30 degrees is pi by 6, when the angle is pi by 6. So if the angle is pi by 6, what is the equivalent wavelength? 2 lambda by 2 pi into pi by 6. Equivalent wavelength is lambda by 12. So it is going to happen somewhere here, lambda by 12. What is lambda by 12 from here? You can divide with 12, so you will be getting L by 15. So at L by 15, that is lambda by 12, it is going to become half of the maximum. A TV tower has height h 150 and the population density and stuff. So when there is a tower, you know, like till what radius it will be covering. What is that radius? Root of 2r h. So till what radius it will be covering? Root of 2r h. So you can calculate the area. Area is pi r square. So population by the area is population density. Population by the area. Pi into r square. R square is this square. So 2r h. 2 into radius of the earth into height of the tower, which will give us approximate answer. Right? Okay. Statement A. In a uniform magnetic field, speed and energy remains constant for a moving charged particle. Yes, because work done by magnetic field is always 0. So energy won't be changing. If kinetic energy won't be changing, if kinetic energy is not changing, then speed is also won't be changing. But velocity will change, direction will change, can change. Moving charged particle experience magnetic force perpendicular to its direction of motion. Yes, because F equals to Q into V bar cos V bar, this force will be perpendicular to velocity and perpendicular to magnetic field. If the force is perpendicular to velocity, work done will be 0, so kinetic energy won't be changing. So assertion is true, reason is also true, and it is the correct explanation because force is perpendicular to the velocity. So work done will be 0, so kinetic energy will remain same and speed will remain same. Cp is always greater than Cv in gases. Yes, work done at constant pressure is more than work done at constant volume. At constant volume, work done is 0. At constant pressure, work done is integral P dV, which is P delta V. Yes, that is correct. So assertion is correct, reason is correct, but is that correct explanation? For isochoric process, delta Q is NCV delta T. Delta U is always N into F by 2 R into delta T. Work done is 0 in isochoric process. In isobaric process, this is NCP delta T. This is N F by 2 R delta T always. Now this is not 0 in isobaric process. It is integral PdV, which is P delta V or NR delta T. Now you can see Cv is this thing plus 0, but Cp is this thing plus some other thing. So I can clearly say Cp is greater than Cv. So the explanation is also correct. The reason is also true. And it's correct explanation also. The rope of length 10 meters and linear density 0.5 kg per meter is lying lengthwise on smooth horizontal floor. It is pulled by 25 Newton. The tension in the rope at a distance 6 meter from the point of application of force. So there is 10 meter rope, you are pulling with 25 Newton. So F equals to M into A. 25 equals to mass into A. This is mass per unit length. This is mass per 10 meters. M into A. Now similarly they are asking at a distance 6 meter. So if this is 6 meter, if I draw the resist part, this length is going to be 4 meter. So why is this accelerating? There is some tension. So tension equals to mass times of acceleration. Tension equals to mass times of acceleration. So they are asking tension, so you can directly take the ratio and you will be getting the tension. The ratio of readings of AC voltmeter across the resistance and AC ammeter in the circuit. Okay, so we'll be taking current as reference. Voltage in the inductor will be leading, voltage in the capacitor will be lagging, voltage in the resistor will be in phase. Voltage in the resistor will be I into R. Now this is, okay, we don't need I into XL, I into XC. Okay, fine. But these two values are 200 they said. So this is 200, this is 200. So these two will get cancelled. What does that mean? It will be under resonance. It will be under resonance. The resultant voltage is going to be in this direction, which is equal to this. So I into 100 is the resultant voltage. Resultant voltage is 500. So I will be how much? I will be 5. I will be 5. Now they are asking what is the ratio of, okay, ratio of voltmeter reading. Voltmeter reading will be how much? 500 by current 5, which will be 100, or I will be getting the resistance value, right? V by I will give us resistance value. Electrons with de Broglie wavelength fall on the target in X-ray tube, the cutoff wavelength. So electrons are coming and they will be hitting the plate and they will be losing the total energy and converting as photon. That's what they are talking about. So electron energy is P square by 2m, P square by 2m. That is totally converting as photon. So Hc by this is wavelength of the photon. So wavelength of the photon you need to find. Total kinetic energy of the electron will be converting as photon. In Young's double slit experiment, how many maxima can be obtained on the screen on both sides of the central fringe? Lambda is given, D is given. So what I am doing, I am finding what is D by lambda. D by lambda is 3.5 or D equals to 3.5 lambda. Why I am doing that? If there are two slits here, there will be bright fringe here. But when you keep going to infinity, what will happen to the path reference? When the point is very far away, we will be feeling like it's almost here, and the path difference is like S1p minus S2p, which is going to be this much, which is t. So when the point goes to infinity, then the path difference is going to be the distance between the slits, which is how much? 3.5 lambda. So here path difference is 0 at infinity, 3.5 lambda. So 0 lambda, 1 lambda, 2 lambda, 3 lambda, 3.5 lambda. So okay, so this is 0. So when you go up 1, 2, 3 lambda. So 3 bright fringes up and 3 bright fringes down, and 1 is here. Totally 7 bright fringes, right? A body is projected with a velocity v1 from point A as shown in the figure. At the same time, another body is projected vertically upwards with v2. What must be the relation between them so that they will collide? So there are two objects moving. I am resolving this velocity v1 cos 30, v1 sin 30, and its acceleration. This will also have acceleration. Now I can sit on this guy and observe this guy. So what will happen? Relative acceleration will become 0. Now when I sit on this guy, I will be feeling an extra velocity v2. But if they are colliding, it must be directly coming and hitting. So the meaning is this v by 2 must be balanced by v2. V by 2 must be balanced by v2. This v1 by 2. v1 by 2 must be balanced by v2. Right? Or else I can say their vertical components must be same. No matter how you can do it. Force, acceleration, time are given. You need to find energy thing. Force dimensions are ml by t square, acceleration, time. Now energy dimensions are half mv square, so ml square by t square. Now for this one, they have given it as already f into a. F dimensions are this, a dimensions are this. Now, but if I want to get this dimensions, I need m is there, L square is there, but t power 4 is coming. So I need to cut one t square. So for that I will be multiplying with t square. But they said this is 2 is x by 3. So x equals to 6. So this question says a sample contains 2 radioactive elements A and B with half-life 51 hours and 2 hours respectively. The nucleus A decays into B and B decays into stable nucleus C. At t equals to 0, activities of both the samples were equal. Anyway, that doesn't matter for the question. The ratio of activity of A to that of activity of B when activity of B is maximum. So this is the question. A is there, A is converting to B, B is converting to C. Now the rate at which it is decaying is minus lambda Na lambda A Na. Now this is called as activity, that the rate at which it is disintegrating. So this is called as magnitude wise, this is called as activity of A. Now similarly B is forming at this rate and decaying at this rate. Now this is called as activity of B, the rate at which it is decaying. Now they asked when this will become maximum. When will this become maximum? When its first differentiation is 0. So when I differentiate this, I will be getting lambda B into dnb by dt. What is dnb by dt? This entire thing, right? And dn by dt is this entire thing. So instead of dn by dt, I can write this. Now when will this become 0? When this becomes 0. So when lambda A and A equals to lambda B and B. This is activity of A. This is activity of B. So what is the ratio? Ratio is 1. The next question, 1 kg of diatomic gas is at pressure 8 into 10 power 4 density is given, energy we need to find. So mass is 1 kg, density is given, pressure is given, density is given. So we need to find the energy. Energy is NCVT, but degrees of freedom for diatomic gas is 5. So CV is F by 2 R, 5 by 2 R. Now nRT I can write it as P into V, but if I want to find volume, it is mass and density are given. So volume is mass by density, all the values are given. Just substitute it to get the required answer. In the adiabatic change, the pressure and temperature are related like something like that. Diatomic gas. So PV power gamma is constant, from there we need to modify. PV power gamma is constant, gamma for diatomic gas is this much, but I don't need V, I need temperature. So I will be using PV equals to nRT and I will be writing this and I will be modifying it, I will be modifying it, I will be modifying it. I need to bring this temperature to the other side. So this is a given question, so answer is going to be 7. Unpolarizer light of intensity I passes through ideal polarizer. Another identical polarizer B is placed behind A. The intensity beyond B is I by 2. See, unpolarizer light is passing through A, so it will be coming out as a polarized light with intensity I by 2. Now if it is passing through another polarizer and intensity is remaining same, the meaning is this axis and this axis are same. So axis A and axis B are aligning along the same direction. Now you are putting some polarizer in between. So C at an angle theta. So what is the angle between A and B theta? A and C theta, and C and B also theta. So A is there, unpolarized light will be coming, so it will be coming out as I naught by 2. Now at an angle theta there is something, so it will be passing as, okay, unpolarized light is coming, there is A polarizer, so intensity will come out as I naught by 2. This I naught by 2 will be passing through C polarizer and the angle is theta, so it will come out as I naught by 2 cos square theta, I naught by 2 cos square theta. But again polarizer B is there, what is the angle between them? Theta. So this will be coming out as that into cos square theta. But this is given as I by 8, so from there you can find cos theta value, right? Thank you.